I'm going to talk about Elasticsearch, obviously. I'm not going to talk about the full-text search capabilities, but rather how to use it to transform your data into information. Before I start, who of you is actually using Elasticsearch? In production? Okay, a couple, that's fair. Anyone already Kibana and Logstash user? Also a couple, but not too much. That's great. So yeah, if you want to tweet about it, I'd like you to use the Elasticsearch hashtag as well, so we can basically see what you tweet about it. Before I start, I may introduce myself. I'm Alexander. I'm a core committer on Elasticsearch. This means features, bug fixing. I'm maintaining the Debian and the RPM package, so if everything is going wrong with packaging, it was most likely me. As committing to a GitHub repo is not a sustainable business model, the company called Elasticsearch around the product is offering development and production support. This means we help you to get up and running with Elasticsearch, and we are also helping you in case your production system goes nuts. Another thing is I'm doing trainings, and I get to talk at conferences and attend them. So my interests are mainly Java, JavaScript, and web applications. I've been working with Elasticsearch since about 2.5 years. I've been working for Elasticsearch, the company, since a couple of months. And we are a distributed company, so we are scattered all across the world. If the world is North America and Europe. And I'm based in Munich, but we don't have an office there, so I do a lot of home office, obviously. So what am I going to talk today about? And before I start, let me start with a very, very common search, and let me show you the search is more than a full-text search today. I pretty much hope every one of you is going to recognize this page. It's a GitHub search page. And if you enter a search query like Elasticsearch in the search box, you pretty much expect to get back results with Elasticsearch. But what is actually happening on this page is way more than just executing a full-text search. If you take a look on the left, you can select by language, and this makes it not only an unstructured search for Elasticsearch, but also it adds some sort of structure to your search, similar to a where query in SQL clause. A search engine also is able to enrich the search results it's going to return to the client. You can see here that the search for Elasticsearch is actually highlighted whenever it's been found in a repository name or in a repository description. Sorting is something which is quite obvious. Usually a search engine is sorting by relevancy, but if you want to take another look at your data, you obviously have to be able to sort by numbers or by strings as well. Pagination is also something pretty obvious, which needs to be supported by any structure which returns any kind of data. And where it gets interesting again, and which we will cover today in this presentation, is the aggregation of data, meaning that you're executing a search query like Elasticsearch, but you actually would want to know what is the distribution of results, like the programming language, like Java, Ruby, JavaScript, and so forth. And this kind of aggregation of data will be covered today in this presentation. Something else which is pretty much obvious for most search engines today as well is the capability of offering suggestions. And as you can see, it's not only returning suggestions, but also enriching them with highlighting again, because the search query has been Debian, and Debian has been highlighted in the results as well. And this is for all kinds of functionality, like did you mean, correcting typos on the fly, before people firing up a search which doesn't return no results, which you pretty much don't want. So before we go on, I'm going to start with the introduction into Elasticsearch. Going to start with this buzzword bingo slide. So if I only have this kind of slide, the pretty much best description for Elasticsearch is a schema-free, REST and JSON-based distributed document store. It's a distributed document store with obviously extraordinary search and data extraction capabilities. And schema-free is kind of a misnomer today because it's more like schema-less. And if you index data into it, Elasticsearch tries to understand what kind of data you're indexing, like a date or like a number, and automatically extract this meta information from the data you're indexing. It's REST and JSON based, so we are pretty much speaking HTTP and JSON, hopefully two protocols, or protocol and object notation. Everyone should be at least capable of understanding of when working with systems. It's distributed. I'm going to show this in a second, what we understand under a distributed document store. And the document store basically means you can index any JSON object of an arbitrary depth, and you can also search on this kind of data. It's open source. It's the Apache license 2.0, so you can do whatever you want with this. It doesn't require a lot of configuration to get up and running. And it's used by a couple of companies, and if you take a look at them, they look like it's only used by like tech-oriented companies, but these are the early days. There are really a lot of companies across every kind of industry which is using Elasticsearch today. Zero configuration is not like a part of my marketing slide before, but it's really that easy. You download the archive, you unzip it, or you untar it, and you're running this one single command, and you're ready to run with a search appliance, basically. The only real dependency it has is Java, so you should have a most up-to-date Java 7, because Java 6 is end of life, but it also works with Java 6 if you're like forced to use it in your environment. The other nice thing about this is you can just run the last command a couple of times in your system, and you immediately have a cluster on your local notebook to play around with the distributed features. So how do you index and search data with Elasticsearch? And this is pretty much the first command you have to execute. I will not talk about curl as a tool. It's a command line HTTP client. It's kind of a Swiss Army knife for everything. So if you don't know it, use it a lot. And what you can see at the first line is the URL which is being referenced, like localhost 9200, which is a port Elasticsearch runs on. Products is an index, product is a type, and one is an ID. And this is how you reference a single document via the URL. And the rest of the document is basically the body. And again, you can see it's a simple JSON object. It's a JSON object with a def, like it has a price object, which inside has a net and a tax value. And if you go through these 4 different values which are inside of it, Elasticsearch actually recognizes that the created at field is a timestamp and is indexing it as a timestamp without having you to configure this upfront. Name is obviously a string, and the price fields are different because net looks like an integer and tax is a float. However, when you index this for the first time, the price.net value will always be an integer, which is not what you want on a live and on a production system. So you can configure this up front, but in order to get up and running, you don't need to. And yeah, tax is a float. And after you've indexed the data with putting it to this URL, you could also just execute a HTTP GET request to get it back immediately. It's basically really a data store, which you can just put data in and get it back. If you want to search data in the next step, you can see that there's another call at the bottom, which searches in the index products with the type product and executes a query for MacBook. And you will most likely get back the first document. So this is all it takes you to get up and running with Elasticsearch. Download, unzip, start, and have fun. I was talking about the distributed features, and there are 2 things you can divide the distributed application into. The first thing you would want to do is replication. This means you're actually duplicating data and storing it on several machines. This offers you some sort of read scalability, because you now have actually more sources to query this kind of data on, and you can execute more queries per second. And the second thing is removing a single point of failure. Even if one system goes down, but you have your data replicated, it's still fully available and available to query. The other thing which is important in a distributed system is the sharding of data. This means you take an index or a collection of data and split it across several machines. The core reason for this is the data gets too big to be stored on a single machine. The other reason for this is you got write scalability, because suddenly you have 2 systems you can write your data to, which basically scales out. And the third thing might be that you want to control data flows. If you have a cluster with an asynchronous strong machines, and 2 are very strong and 2 are very weak, you may want to index your current data and query your current data over the powerful machines. So what means distributed? Distributed basically means that you can fire up a single node with the command I just showed, and you can create an index. In this case, it's an orders index and a products index. And when you create an index, you can actually define the structure of an index in a distributed environment. In this case, you would divide the orders index into 4 parts, which is the number of shards, and you want that each part is replicated somewhere else in your cluster. This is some sort of contract you're defining when creating an index. The second example with the products index means creating an index with 2 shards, but you don't want to have it replicated somewhere as a kind of backup. So if you're firing up a second node, this basically means that the contract with having 4 shards and 1 replica for each is going to be fulfilled on the second, on both nodes. This means every data is basically duplicated now, but it's available, it's completely available. And there's a notion of so-called primary and replica shards. The one with the green background are the one where data gets indexed first and then it gets copied to the replica shard. And the contract of the products index basically means I want to have 2 shards, but I don't want to have any backups. So if in this scenario the second node fails, I still have my full data of the orders index, but I will obviously lose half of my data of the products index. If you start up a third node in this scenario, the products index will not change at all because the contract is already fulfilled, but the other shards will actually distribute across a freshly added node, and you can now shut down any node and all of your data from the orders index will still be available. So talking about Elasticsearch as a product is really nice, but there's actually a whole ecosystem around, and since we founded the company, we tried to create an ecosystem like clients, like Kibana and Logstash, but the first thing you actually have to know is that it's very easy to extend the functionality of the Elasticsearch core product. It's basically just a Google Juice application, and we provide hooks for everything. So you can create your own plugins, like your own Lucene analyzers, like your NLP functionality, like your own aggregation functions or whatever you want. Put it in a zip file, and this is it to install it as a plugin in your Elasticsearch nodes. So it's really easy to extend. We also have clients for many languages, but the client is basically just a very thin layer of code between the HTTP layer of Elasticsearch and your application, but it makes things actually simpler if you don't have to care for opening HTTP connections and closing them. And last week we released a couple of clients for Ruby, Python, PHP, and Perl as official upstream clients, which can be used to create your own object mapper, for example. And there's also a couple of community-based efforts for JavaScript client, for Scala client, for Clojure client, and many more languages. And even there are more clients for the first 4 languages written by the community because they wanted to solve a certain use case. Also, Kibana is something which I'm going to show in a second, which basically allows you to get a graphical overview of your data which is stored in Elasticsearch. It's a small JavaScript application which queries Elasticsearch and creates charts and allows you to create dashboards you can share with other people. I'm going to show that in a second. Logstash is a log file aggregator which basically takes a pile of log files and indexes them into Elasticsearch, but is able to enrich them, like with adding geo-based data for an IP address, so it's easier to query. And we also have a Hadoop integration which allows for faster queries in some cases because we can execute them in memory and return faster than a usual Hadoop job would. So this was the introduction. The next step is that we are going to index some data, and I'm going to show how to extract useful information out of it. And the question is, what is data? And in my terms, it's whatever provides value for your business. And there's some kind of obvious data, which is in domain data, like your orders or your products if you're an e-commerce shop. This might be internal, but it also might be external. If I'm a social media company which analyzes constant data streams of Twitter or Facebook, this is my core product value, and this is the data I need to analyze. Same goes for Gmail and emails. They need it for spam tagging and filtering. But there's also less obvious data, which is, in this case, as a sample application data. There's log files, which might tell you when you need to fire up your next EC2 instance because you're getting too much requests for your static files. There are also metrics like in-memory values from your application, which you would want to monitor and see what happens with it and react on certain events. If you walk through a company, you will see that there's tons of more data like this, not domain data, not application data, but maybe something which is there on paper and you would want to have it digitalized or whatever. And you will see there's many things of data you would want to index and obviously ask questions. So you can ask questions to your data, and these are simple questions, but you still want to know. Imagine we have this orders index I just showed you with the 4 shards and 1 replica, and after some time, you might want to know how many orders are in there, how many orders we did get last month, how many orders are coming in per day, what is the average revenue for my shopping cart inside of this order is actually quite a valid question, which will come for your controlling department. and also the average shopping cart size per order, and you want to maybe know this by hour in order to find out when is the peak shopping time of my customers. These are all questions which sooner or later will most likely pop up. So what can we do? First, we are I'm just showing you this as a format in order to understand the next queries I'm going to show you. So an order is obviously quite a complex beast, but in this example it gets a creation timestamp and it has a total. And usually an order has items and a tax and a currency, and orders are getting really fun if you start with item cancellation out of it, because then you have to recalculate your whole shopping cart. How many orders are created? This is actually something which is really easy to answer with Elasticsearch, because all you have to do is an HTTP GET request on the orders/order/_count URL, and you're getting back a number. But maybe this is not the most complex question you want to have answered. If you want to know which orders were created in the last month, again, this is very simple. You just call this order endpoint, this count endpoint again, but you add a so-called range query, which simply limits all the results between the first date and the last date, greater than equals and lower than. So the next question might be, how many orders were created per day? So you actually have a bucket of 30 days for the month of September, and you want to know the 10th had 25 orders. So you still need to filter by month, but you also need to create buckets and count per day. This is where faceting and aggregation actually comes in. If you remember the GitHub screenshot of the beginning, the languages and the aggregation information also were simply a facet. It was just a count for the Java language. It was just a count for the Ruby and the JavaScript language. So it's just some sort of bucketing which has been happening there. And you can also simply count by day in this case. You create a so-called facet, you give it a name, like created in this case. You specify a type, like date histogram, and the field created at, which was part of the orders we indexed. And you have to specify an interval. This could be 1 week, this could be 1 month, this could be a quarter of the year, depending on which scale or kind of scale of data you want to look at. And you obviously again need this kind of facet filter, which simply filters the data for the specific months. So what is the average revenue per shopping cart? This is a thing which is slowly getting interesting for your controlling department. And what you can actually do is you can create a so-called statistical facet, which actually takes all the numbers inside of a field, adds them up, creates some statistical values like min, max, average, standard deviation, and so forth. And you can basically, what I did here is I'm accessing the total value field, and I'm multiplying it with 0.1 in case we have 10% revenue in each shopping cart. It's most likely a simple calculation because you will want to have this per product if you have a huge product catalog. And I'm adding 2 because most e-commerce retailers make their money actually with shipping costs. And they can easily add a static amount of money for shipping costs, and this is where most of the revenue comes at with low budgeted orders. So this is all nice, but these are not really complex questions. I can do this with a little bit of SQL as well. So where it gets really interesting is to apply several facets at once. Like I'm taking the input of one facet, like the statistical one, and I'm bucketing this over time, like per day. So what is the average order value or the average shopping cart size per order per day? And this is where questions are slowly becoming more complex, and this is where it's going to be complex for Elasticsearch because you need to combine every type of a facet arbitrarily. You can do this with the upcoming release of Elasticsearch 1.0, which is really flexible in this case, and I'm going to show you later on how this works. And obviously you can also do this by simply changing your data and re-indexing it, by already having an aggregated field in a pre-computed computation and putting this into the index and then running a statistics facet. But this is a big problem because every day your question changes and you would need to change your data as well and re-index, and this doesn't scale obviously. So keep this question in mind and we come back later to that and how to solve it pretty easily. Another step you want to do, like when you now started to extract your first kinds of information, the first bits of information, and you know what's going on with your orders maybe, is, your boss asks you to create the daily Excel sheet he would want to have by email at 8 a.m. And you start hacking away this wonderful Excel library for Ruby and Java, and no. You don't want to be the extended arm of your boss and grabbing through log files or like order data and do this every day on a different manner. And JSON itself also is not a management compatible notation, which is actually returned by Elasticsearch, so you can just forward the request to your boss and tell him to be happy. And also writing your own visualization app for all kinds of stuff. This is not going to work in the long term. And this is where Kibana comes in handy, because Kibana is basically a small thing on top of Elasticsearch. It's an own JavaScript application which is able to query Elasticsearch, get back the data, and make wonderful graphs out of it. Kibana itself, you can basically just clone the GitHub repo, put it on a web server, and that's it to get up and running initially. What you can do with Kibana is to create this kind of dashboards. In this case, it's log file data from an Apache web server, which is maybe interesting to know about the distribution, how many HTML files you're actually sending back to your client, how many PHP files, how many images, and you can see at the top that there's a query for file endings for HTML, PHP, PNG, GIF, and CSS. Then you can see a distribution over time, so you can pretty much see that there's a traffic peak at noon at this web server log, so maybe it's a lunch planner, I don't know what this kind of site may be. And you can see you can use a pie chart. So this is a completely configurable dashboard. So you can pretty much fit this on your use case, and you can save a dashboard. You can share it with your boss, and he can like drill down on the data further if he wants. If he like just want to know how many people from China are accessing HTML files, this is very easy for him because he just needs to modify a query, and the query language is pretty simple. Yeah, it even has a dark theme. No, I mean, the important part of this image is obviously that there are 2 problem zones inside of this image. And if you have a web server log spanning over 10 Apaches, it's going to be pretty hard to find this problem without the help of visualization. So this kind of tool is not only an aid for your boss, but if you're indexing Apache log files, it can really help you to like identify problems, find out what is going wrong, and at least know that something has gone wrong at 5 a.m. This is not most likely not the time you're going to be awake and check all your web server log files. Another thing you can optionally do in your releases is you can use geolocations of the data and like draw it on a map, and you could see like where the people are actually coming from visiting your site, or in the context of your orders, you can actually find out where the people are ordering from. And another nice functionality is that this geolocation not only works for specific location points, but you can also, if you index the ISO country code, like DE for Germany, like DK for Denmark, you can use a special widget which basically draws you this country map and shows the distribution on top of it. As you can see in the widget below, you can also show trends. Like you can see that the tweets which are split by language in this example, that the Turkish tweets are actually rising by 8.33%, so you can see what is actually happening and changing in your application. And this is the kind of dashboard information your boss most likely wants. So this was a small overview of Kibana. Kibana is a very nice tool. You can create these dashboards. You can like let them self-update every 30 seconds, so you can just rack mount a huge LCD in your wall and see actually what is happening in your live system. But the thing is, you're always looking at data which is kind of in the past. And the next step you actually would want to do is like to know stuff now, because there are definitely events which can happen, which you really want to know in the moment they are happening. And if you take an arbitrary application, totally independent of how it's been implemented, these are events which can absolutely happen. Like the first one, you have a checkout application, and it suddenly takes more than 2 seconds for your payment provider to process a response you sent. This is not a problem per se, but this might be a problem because suddenly your payment provider is offline and you're not going to be able to process any checkout, and you might just want to call them about that. Same goes for credit card fraud detection. Maybe it's a huge order of several 10K, and the fraud detection kicks in and cancels this kind of order. Maybe you want to know about it and process it manually. You're sending out a television commercial, your visits are exploding, you might want to spin up several EC2 instances. And if you have a sort of voucher in this television commercial and it's gone after 1 minute of this television commercial being sent, that might be a good PR for you. Another use case from an operational perspective is the memory usage exceeds the physical memory. This basically means that your process has to swap out and is going to be slow. This doesn't mean that your application is offline, but it might indicate a problem after all. And these are all events which are not like bringing your application down, but you want to react on this kind of events and you want to know it in the moment they're happening. And you don't want to check Kibana from the log files of 5 a.m. and see, maybe I should have done something about that. If you don't know, this is from Java Vault. This is a library called Metrics, which is a pretty awesome thing. It's written by Coda Hale, who also wrote the Drop Wizard web framework. And the most likely library like that in Java World is Jamon, short for Java Monitoring. It's a library which has been around for 10 years, and it basically allows you to gather live statistics inside of your application. And you can like have several different types of metrics, like a meter, which can measure events over time, like requests per second. You can like have a timer, which can measure the runtime of something, like the connection to your payment provider API, and create statistic data about it. And it has a very nice feature about health checks, which basically allow you to check if something inside of your application works. A common health check would be to connect to your database and see if it works. Usually people now tell me, but I already have my monitoring host connecting to my database and see if it works. But it's not a useful information if you know that your monitoring host is able to connect to your database. It's a useful information to know that your application is not able to connect to your database. And this is where health checks come really in handy. And metrics can report to Elasticsearch. And even if you decide not to use Elasticsearch at all after this talk, I definitely encourage you to check out the metrics library because it's awesome. The metrics library from a Java point of view is pretty easy to use. You have one huge class called the metric registry where all the metrics are like registered in. It's easy to create a meter or a timer, as you can see here. The meter was the one to like collect statistical values over time, like the requests per second. The timer one would be the one you use when you want to measure how long your external connection to your payment provider duration is. But the main problem with the metrics library is this is always live data. So it's being updated in the background. And again, you need to store this kind of live data sometime everywhere to like create statistics about it. And this is where Elasticsearch comes in. You can basically configure the metrics library to report every minute, most likely, to Elasticsearch, have this kind of metrics stored there and use it for like pre-processing later on. The metrics Elasticsearch reporter uses HTTP, so it doesn't need a huge Elasticsearch dependency. It's independent from the Elasticsearch version, so no matter if you use the most up-to-date one or a little older one. And it has another really nice feature, which is called real-time notification via percolation. So real-time notification basically means you can do something if you hit a certain metric, like the disk space used for the WAR file system exceeds 90%. You may want to know about that. The reporter itself is available in the GitHub repo, but before we go on, I should explain what percolation is, except a nice feature inside of Elasticsearch. The normal process of indexing data is that you index the document and run a query against it, like I'm indexing a MacBook, and I'm querying for MacBook, and I'm getting back this kind of data. But imagine I'm searching for a MacBook with a price of 200 euros, which is not that much. I won't get a document back, but I may want to register this query to get notified as soon as this kind of data is indexed. And this is a classic use case for implementing a price agent. And this is where a Percolator really comes in handy. And you can, if you take a closer look at your data, you can imagine pretty crazy stuff with it. There are customers using it for classification, like getting back some sort of text and adding this text to the document automatically. And obviously you can use it for this kind of metrics application as well. So this is how you basically create a percolation support for it. So you have an Elasticsearch reporter, which basically runs every 60 seconds to report its data to Elasticsearch. You register a notifier, like a pager notifier in this case, and you apply the names of the metrics. In this case, every metric the percolation should run against. You have to sort of register it. And then you implement your pager notifier class and whatever should happen there. Most likely you want to trigger a call or you want to trigger a RabbitMQ message, which then gets forwarded to another application, which takes some sort of action. Together with the metrics Elasticsearch reporter, which is on the Elasticsearch GitHub account, there's also a small sample application called Cockpit, which is basically two applications. One is a Java application, which constantly reads out an open stream from the US government, showing which site is visited right now, like nasa.gov or whatever, and it takes some metrics about that and collects how many lines per second are read from the stream. And the other application is this one, which is a small Node.js application, which basically just can draw an awesome graph using D3.js, obviously. And you can see the green rectangle on the left side, and this is basically the result of a notification being sent to this Node.js app, and it's forwarded via WebSocket connection to all the clients, and this means it's basically real time. The moment it happens in the metrics reporter, it's reported to the client. So if you want to play around with it, check out the small application and see how you can again build your own dashboard and rack mount it to your wall in the rack mounted via LCD panel to your wall. Yeah, the next step would obviously be to go from data to insight. So right now we went from data to extracting some basic information, but seeing the limitation of this kind without having to reindex your data. We are able to get a first overview about it. We are visualization, and we are finally able to get notified about it. But what we really want at the end of the day is we want to know what do we need to do next. So it's more like getting to the predicting business. And the thing about predicting stuff is that it's basically pretty complex. The most important thing is that you need long-term data. This is the only chance of being able to know what's going to happen next. Visualization is an awesome start because Kibana will help you a lot to find out when you reach the next possible level of scale where you need to add hardware to something. But the most important thing is you have to sort of in-source this kind of data. You can't just push it to some service and hope it will get back to you with useful information. So you have to know your data, and you have to know your data format. And the last thing is, that's not a problem. There are lots of people inside of your company which have questions about the kind of data you're indexing, and which will have awesome ideas what they always had wanted to know but didn't dare to ask because you didn't show them a solution to easily extract data from a huge amount of data. So there's a new feature called aggregations, which will come up in the Elasticsearch 1.0 release. And the nice thing about aggregations is basically you can take the output of a facet operation, like the date histogram, the bucketing into values per day, and use it as an input for the next kind of operation, like calculating the average value of your shopping cart. And if you remember what is the average shopping cart value per order per hour, we can now pretty much and easily answer that one. This looks a little bit more complex than the last one, but if you take a look, it uses this AGGS aggregations feature. You specify a nice name for it, average shopping cart per hour. You again use the date filter and the date histogram facet, but you use the aggregations field to calculate a total of the average. And this is what you can now actually have. The drawback with this solution is it actually creates a bucket per hour and an average value. This means for 1 month you're going to have 30 times 24 buckets, which makes it 720, I think, or something around that. And this is not something you want to draw easily. So what you actually wanted to know most likely is, are the most of my customer, or the average value of my shopping cart, is it higher between 15 and 16, 4 and 5 o'clock, or 5 and 6 o'clock? And you would have to change this query a little bit and still use a histogram facet or histogram aggregation, but using the script to access the date from the created at field and just create a bucket per hour of the day. And this means you can easily answer way more complex questions with the aggregations, because you can go arbitrarily deep, obviously to the cost of some performance, because these are all in-memory calculations, but at least it's possible. And this one would create exactly 24 buckets, each for 1 hour, and add up the average value for your shopping carts. So this is what I encourage you. Ask complex questions and try to extract them out of your data. For example, you got product page views. which might be interesting, but if you can combine the sum of product page views with the price range, you can actually find out pretty easily if you're a low budget shop or if you're a premium shop. So you can actually see pretty good what your customers are thinking of your shop, instead of like having the perception what you think what your shop actually is. Another thing might be geolocation. So imagine a huge furniture house, like sending out a newsletter twice a week, and they may want to find out